guys. Day 2 of circles. Today we're going to talk about arcs and central angles. If we take a look at this circle here, we notice that there's an angle that's inside the circle. This angle is coming from the center point, so we call that a central angle. So a central angle is an angle with its vertex at the center of the circle. So angle YOZ is the central angle, and we would name it angle YOZ. If we look at this circle, it's darkened on your picture, but you might not be able to see it. Darken from Y to Z. Even if you just have a pencil, just darken it. That is called a minor arc. When you think of minor, you think of something that's smaller, and minor arcs are smaller. A minor arc measures less than 180 degrees. 180 degrees would be half of the circle, and this is clearly less than half of the circle. When you name a minor arc, you use 2 letters. In this case, we would name this minor arc YZ or ZY. YZ, and make sure that you have the symbol for an arc on top of it, which is just like a curve. What happens with a central angle and a minor arc, their measures are actually the same. If I have a central angle and I say that this is 61 degrees, my minor arc that is intercepted by this angle is also 61 degrees. So let's write here in this blank spot here that our central angle is equal to our minor arc. All right, so if there's a minor arc, you're probably thinking, oh, there might be something called a major arc, and you'd be right. So in our picture here, let's darken from A, and let's go through B all the way to C. Clearly that is more than half of the circle, so that is called a major arc. So that is greater than 180 degrees, and it has to be named with 3 letters. The 3 letters give you direction. If I just said AC, you wouldn't know if I was talking about this guy right here, AC, or this way to AC. So when you have 3 letters, it gives you a direction. If I'm going to name that major arc A, B, C, with my arc on top, I would know that A is my starting point. I'd continue through B, and then I would end up at C. Our last picture here is exactly half of a circle. So darken in the bottom half of the circle. That is called a semicircle. A semicircle is exactly 180 degrees. We know that because in an entire circle there's 360 degrees. In a semicircle, we name that with 3 letters also. Only because it gives direction. X, Y, Z would be the bottom half of the circle and not talking about the top half. All right, let's take a look at some examples here. Actually, let's add in that that's exactly 180 degrees. All right, well, let's take a look at the examples. Let's take a look at number 1. Number 1 comes from the center point, so it's a central angle. In the box up top here, we wrote that the central angle is equal to its minor arc. So if we look at our picture here, if our minor arc is 72, our central angle is 72. So angle 1 equals 72 degrees. Nice and easy. You might want to have your calculator out, all right, because we're going to be doing some adding and subtracting of some numbers here. All right, so we want to figure out what angle 1 is. So if we want to figure out what angle 1 is, we also need to figure out what this minor arc is that goes with that central angle. Well, I know that this is 40 degrees, and I know that this is 225 degrees, this major arc. So I know in a circle there are 360 degrees. So if I take 360 and I subtract 225 from it, and then I subtract 40 from it, I'll end up with what's left. So 360 minus 225 minus 40 gives me 95 degrees. So my arc here is 95 degrees, which would make my central angle 95 degrees. So the measure of angle 1 is 95 degrees. Let's take a look at number 3. They want to know the measure of angle 1. So the measure of angle 1 goes with the intercepted arc right here. It's a minor arc. This is 30 degrees. But do we agree that there is a diameter in this picture? And if this is a diameter, that makes this whole piece a semicircle. And we said in a semicircle, there's 180 degrees. So if there's 180 degrees for the entire semicircle, and we know that this is 30 of it, I just have to subtract my two numbers here. 180 minus 30 gives me 150 degrees. So my minor arc is 150 degrees, which would make my central angle 150 degrees. Let's take a look at number 4. We know that this part here is 130 degrees. I know I have angle 1 right here, which means I should figure out what this minor arc is. Again, do we see some diameters drawn in here? This is a diameter. So just like in the previous problem, if this is a diameter, I know the whole thing is 180 degrees. I know from here to here is 130 degrees. If I subtract my two numbers, I will figure out what my minor arc is. So 180 minus 130, 130 is 50 degrees. So my minor arc is 50 degrees, which would make my central angle 50 degrees. The measure of angle 1 is 50 degrees. All right, let's take a look at number 5. When I have problems like these, I don't jump right into what they're asking me. I want to take a look at the whole picture. Usually you can figure out everything before you even start the problems. If I see angle AFE as 63 degrees, I know that the minor arc is 63 degrees. I know if angle DFE is 90 degrees, I know this minor arc is 90 degrees. Now let's look at some things that could help us. In the previous two problems, I saw some diameters. Do you see a diameter or two diameters in this picture? I see this diameter right here. All right, so that means this entire part from here to here is 180 degrees. In the last problem, I took 180 and subtracted what we knew. Well, in this case, if this is 180, I might have to subtract 90 and 63 to get CD. Or I could add the two numbers up and subtract from 180. So let's do that. 180 minus 90 minus 63. And I've got 27 degrees for this arc right here. Now, something else that jumps out at me. I see that this angle is 63 degrees. If I do this, what does that mean to you guys? That's right, vertical angles. So if this is 63 degrees, this is 63 degrees. And if the central angle is 63 degrees, so is the minor arc, 63 degrees. All right, so just like we did over here, If this is a diameter, don't you guys agree? This is also 180 degrees over here. And if I do 180 minus 63, that'll tell me how much BA is. So 180 minus 63 is 117. All right, I'm going to show that work here so that you know where that's coming from. All right, over here I did 180 minus 90 minus 63. That's where the 27 came in. So now, if you take a look, I know the measures of all of my individual arcs. Down here, let's take a look at what they want. They want to know ADE. A to D to E. Well, look, if I go this way, oh, I already passed E. That's the wrong way. A all the way to D and then to E. So all that means is I have to add all of the numbers that I come across. I've got to take 117 plus 63 plus 27 plus 90. 117 plus 63 plus 27 plus 90 gives me 297 degrees. Another way you could have done that is there's 360 degrees inside of a circle, subtract the 63 degrees. Let's take a look at B, ADB. So A to D to B, A to D to B. So let's add up those numbers. If I go A to D to B, I get 63 plus 90 plus 27 plus 63. Add those numbers up. 63 plus 90 plus 27 plus 63 is 243 degrees. Find the measure of arc CE. CE. These two numbers need to be added up. 27 plus 90 is 117. And the measure of arc ABD. ABD. So I need to add 117 plus 63 plus 27. 117 plus 63 plus 27, 207 degrees. So when you have to do problems like this on your own, I highly suggest go through the circle, identify all the missing parts, then complete the problems, and you'll be successful.